Sixth grade lesson 10.2 is exploring area of triangles. And before I get to drawing you a triangle, I'm going to dust off those cobwebs from the last lesson. We had rectangles and any parallelogram. If we wanted to find the area, the flattened surface, if we wanted to cover that whole flat surface, we would multiply its base times its height. And that would give the area, the whole flat surface of that rectangle or parallelogram. What if I had a triangle? Let's explore a little bit about triangles. What shape do I get if I cut from corner to corner, opposite corner to opposite corner on a rectangle? I end up with a triangle. And I get two congruent triangles, two same size triangles, right? What if I had cut the other direction? What if I went this way instead? I get two congruent triangles, this one and that one, right? Let's look at a parallelogram, just kind of out of curiosity. What if I cut that corner to corner? Look, two congruent triangles, right? This one and then this one. They would fold up and match, or they would fold up and be the same area anyways. So what you would find if you played with this for a while, that every triangle is exactly half of some unknown parallelogram. So if that's the case, I can use that information to my advantage. Let's go back to this parallelogram. If I had asked you, hey, will you find the area for this triangle here? And you said, well, Ms. Sanchez, you haven't taught me how to find area of a triangle yet, so no, I can't. But could you do it as a detective? If we know these two things, if we know how to find the area of a parallelogram, base times height, or rectangle, and we know that a triangle would be exactly half of that, then let's see what happens. I know my area of the whole rectangle is base times height or length times width. Fill in my dimensions, 6 times 5. The area of the whole thing is 30. Let me shade that in here for us. This whole thing is 30. If I only wanted to know half of it all, then what's only half of it? Right, it's 15. That doesn't show up. Let me use a different color. Area of that triangle is 15. It would be 15 here, and it would be 15 for this triangle, and altogether would be 30. So this lesson just wants you to recognize that you can still find the area of a triangle if you know its base and you know its height. You treat it like the area of a parallelogram or a rectangle, and then you cut that value in half because you're ignoring half of it. Let's see a few examples. Okay, let's say I have this parallelogram that has a base of 9 and a height of 4, but I'm telling you I want the area not of the parallelogram, I want the area of the triangle within that parallelogram. Start by finding the area of the parallelogram first. Area equals the base, which is 9, times the height, which is 4. 9 times 4 is 36. Let's say that's meters, just so that we practice having meters to the second power, units to the second power, area, two-dimensional. Now, that gives me the area for all of this. But remember, I only want half of it, right? That triangle is just the half of it. So I will cut this number in half. Cutting in half, if I'm cutting a candy bar in half, how many people are getting a piece? 2, right? Cutting in half is dividing amongst 2, or dividing by 2. So we will divide by 2 to find out how much half of it is. The area of that triangle is 18 meters square. So that's it for this lesson. They just want you to recognize, okay, I can find the area of the parallelogram And then when I've got the area of the parallelogram, to get the triangle within that parallelogram, I just cut that number in half. That's all they want you to do for this lesson. So go ahead, you're basically getting extra practice on the area of parallelogram, and then getting the area of that triangle by cutting that in half. Think you've got this. Go get it.